In today's episode, calculations involving significant digits. So you measured two numbers and now you want to do something with them. You want to add, subtract, multiply, or divide. Also known as why nearly everything you learned in math from your teacher is wrong for measured numbers. Most of the time in math we deal analytically, not with practical things like what does this number actually mean. In math we kind of assume that when we see a number that it is exact, that if you see a 7 it really means 7.0000, exactly 7. But in chemistry or any other thing where you actually are measuring numbers, we know that there's no such thing as exact, so we have to use significant digits. So what does that mean? Well, here are a few examples. Let me show you what we're going to do. Here are some calculations, and I am going to write the correct answers. I'm going to write the correct answers over here to the right. 4.4, this is true. By the end of this lesson you will know how to do this. This is not a lie. 4.4 times 1 is, drumroll please, that's right, it is 4. 2.7 minus 0.025 is, let's think about that for a bit, 2.7, yay. About this one, 0.001 times 8,888, missed comma there, and we get, drum roll please, what's the answer? What do you suppose that is? Oh, I'm gonna go ahead and say 9, yay, 9. And how about this last one? 76,824.33 divided by 1 is, of course, as you all already can guess, 80,000. That is the correct answer. But why? Because of significant digits. You got to look at significant digits. Here's the basics. You got a problem. You're using measured numbers. Presumably. In chemistry, you usually work with things that we measured in a lab. But the answer to your problem cannot be more precise than the numbers that went into the problem. Remember, every time that you write a number down, as we learned in the lab that we hopefully did, the way you write it tells you something about how it's measured. This 1 here, it's an estimate. We don't know that it's 1. Maybe it's 2. Maybe this is 4.5, you know. Maybe this is 0.002. That, if there's only one digit there, it's an estimate. We can't really trust it completely, and so we don't want our answer that we give to show all sorts of tiny little precisions whenever we're not even sure what this number was. That wouldn't make any sense. So we don't want our answer to be more precise than what we use to go into the problem. So we come to this. Every time you do a calculation, you must round the answer to reflect the number's precision that went into the calculation. Now that's a big old mouthful. That's a long sentence with lots of capital letters that are kind of scary. So what do they mean? You can write that down or not, I don't care. Here's the idea. Here are the rules. When you're adding or subtracting two numbers, look at the number of decimal places. Now the number of decimal places, it's real big. It's real big in big red letters. Big red letters often mean that you should pay attention. When adding or subtracting, I should probably highlight that as well, because the rules are different when you're multiplying or dividing. When you're adding or subtracting, so if you want to do an operation and round it correctly, first thing you want to ask is, well, what did I just do? Did I add and subtract, or did I multiply or divide? And so we're going to look at the decimal places in this case for adding and subtracting in the numbers that you're using. So in this example, here are the numbers that I'm using. You know what? If I'm showing this in class, that's not nearly big enough. We need to make those bigger, 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 bigger. How about that? It's a little better. Hopefully that's a little better for you. We have 14.985 plus 33.55 minus 8.0. Those are our numbers, and we're going to add them and subtract them. And so when we do that, we actually get an answer of 40.535. Now that's not rounded yet. That's just what you get. That's what you, if you type this into a calculator, that's what it's going to say. I'm not saying that's the right final answer. I'm just saying that traditionally in your math class that would be the answer that your teacher would expect you to write. But we know that we need to count, we need to round that answer to reflect the numbers that went into it. So we look at the numbers that went into it, and the first number is 14.985, and we ask ourselves, how many places to the right of the decimal point are there? And the answer is 3. What other numbers did we use? Well, we used this 33.55, and it has 2 digits to the right of the decimal, and this 8.0 has 1 digit to the right of our decimal. So, what did we just learn? We learned that, well, I don't know. You might have several numbers. That's okay, we don't care. All we care is the one that has the fewest digits after the decimal point. That's how many digits our answer must have. No more, no fewer. Let's go back. If we look here, here are the numbers that we use to go into our answer. And what did we just learn? Let's probably leave that for a second. You guys like to write things down, right? Do a little song and dance. Maybe just pause it. Let me know when you get this. All we care is which one has the fewest digits to the right of the decimal point. All right, now let's go back. So which one of these has the fewest digits to the right of the decimal point? Well, clearly the 8.0 does. It has 1 digit to the right of the decimal point. That means that our answer here should be rounded until it also has not 3, not 2, but 1 digit to the right of the decimal point. So that would be 40.5, and then the 3 will go away and the 5 will go away, and those do not round up. So we are done. That is at 40.5 is the answer to that question. So here's a few more. If we go 12 plus 5.8, we get 17.8. But when we round it, this has 0 digits to the right of the decimal point. This has 1. So our answer should have 0. How do you write that with no digits to the right of the decimal? Dramatic pause. 18. Over here, 2.34 minus 1.172. Oh goodness, can I do that one in my head? We got 1.168. How about that? Maybe that's right. We'll see. And that's what your calculator says. But now we're going to count digits to the right of the decimal. We got 2 here. We've got 3 here. And so we want 2 in our answer. This is not 2 digits to the right of the decimal. That is 3. So we want to round it to 1.16. The 8 goes away. However, since 8 is bigger than 5, we're going to call it 1.17, round that up, and that is our answer. Down here we have 71.745. If we just put that into our calculator, unless of course I'm wrong, but I don't think I am. I could be. We'll find out. And here we have how many digits to the right of the decimal point are there? None. And here, well, we don't care. There's none. We want none in our answer. So we don't want 71.745. We want 71, but that 7 we round off is bigger than 5, so the 71 turns into 72. So that is how you do addition or subtraction. But what about multiplication? Or its tricky friend, division. Tricksy habits as it is. Good news, the rules are exactly the same. Oh wait, nope, nearly exactly the same. The rules are nearly identical. So what were the rules for adding and subtracting? We looked at the digits, we counted the number of digits to the right of the decimal, and the smallest number of that is how many digits to the right of the decimal we wrote in our answer. We're going to follow almost exactly the same rules when we multiply or divide, but there's a change. Replace the digits to the right of the decimal place with significant digits. Yay, significant digits. When you multiply or divide, you don't count decimal places, you count significant digits. Well, what does that look like? Well, here are some things. Let's see. Woo! 8.0 times 6.0 is 48. And now that's what your calculator is going to say. Your calculator is going to say 48. And so we go back and we count significant digits. I'm going to do this quickly. This guy has 2 significant digits. This guy has 2 significant digits. Our answer already has 2 significant digits, so it is correct. Yay us. What about 8.0 times 6? This has 2 significant digits. This has actually just 1 significant digit. So this time, although the answer is 48, we need to round it to 1 significant digit, which would be 50. How about 1 times 55? Well, this has 1 significant digit. This has 2. Our answer should have, how do you write 55 with 1 significant digit? Well, you round this 5 off and it goes to 0, but that goes up, so you have 60. 1 times 55 is, of course, 60. 38.26 divided by 8.5. I don't think I'm going to try to do that one in my head. I'm going to get my trusty calculator, and I'm going to divide those, and I see that my calculator, oh my goodness, my calculator spit out a big long string of digits. It says 4.50117647, and I suspect it goes on further, but it doesn't matter because we're looking up here, and this has this first number we used had 4 significant digits, and this one has 2 significant digits. So our answer should have 2, so we keep the 4 and the 5 and round everything off. 4.5 is the answer, and that's how you do it. If you wrote 4.501, that would be wrong. If you wrote 5, that would be wrong. You want 4.5 as the correct number of significant digits. So we covered addition and subtraction, we've covered multiplication and division, but what if we have both? Well, it's simple. Just follow the order of operations and round before you change the operation type. Well, order of operations, here we have 8.7 plus 9.05 times 37. So what's the order of operations? What comes first, multiply or add? Well, I'm going to go with multiply. So 37 times 9.05 is 334.85. And now I'm going to add that to 8.7, but that is a different kind of operation. So before I can do that, I need to round. Now, if I multiplied right here, I wouldn't need to round until I was done multiplying all the numbers. But since I'm changing the kind of operation, I need to now round before I go. So I look through here, and I have 3 sig figs here, and I have 2 significant digits here, so I want 2. So I want 330 is how I would write that. So 330 then is added to 8.7. 330 plus 8.7 is 338.7. However, this has 1 digit to the right of the decimal point. This has 0 digits to the right of a decimal point, so our answer now should have no digits to the right of the decimal point, so the 7 goes away, which means it's 339 is how that would round. So to summarize, don't forget, every time you round a number, ask yourself, was this addition, subtraction, or was it multiplication, division? And then round using the correct thing. If you use multiplication or division, significant digits. If it's addition or subtraction, you look at decimal places.